Before we progress, I just wanted to take this opportunity to take a picture of you guys. And I want you to show me the rock out symbol. This is for my wife, because she doesn't know I'm here. All right. So, in this talk, we're going to be talking about building and scaling Angular apps on Microsoft Azure. This is going to be somewhat different than you'd expect from other talks. So let's start off. My name is Maciej Misztal. I work for 7N, and I'm currently in the employ of a Danish company called Schultz in the role of a cloud technical lead. Typically, those are the technologies which I work with on a daily basis, or I'm very, very passionate about. And as you can probably tell, I have a strong backend background, but I also do happen to work with Angular. So the first thing that I'm going to talk about is a service from Microsoft, which is called Azure DevOps, recently known as VSTS. So when you set up an account on Azure DevOps, what you get is project management, source control, also continuous integration, continuous deployment, test management, and private package feeds, including an NPM feed. So you probably heard that quite recently, Microsoft has acquired GitHub. And they also have a very, very cool policy on open source projects. So if you have a project on GitHub, which you'd like to build, you are eligible for up to 10 concurrent jobs or pipelines on Azure DevOps. So this extension is freely available from the GitHub marketplace, and it costs you nothing. Alternatively, if for some reason you're not comfortable with hosting code on GitHub, you have the option to host a public project on Azure DevOps, and I believe this also makes you eligible for up to 10 concurrent pipelines. It's a great way to try stuff out. So this is a great all-in-one solution capable of building any app on any platform. So that includes Node.js, Angular, PHP, .NET, Java, you name it. Even Xamarin apps can be built on it. So assuming you have a brand new project, what the first thing you want to do is to set up some proper pull request validation policies. How many of you guys have strict control processes such as this? Not many. So hopefully this will be of benefit to you. So first off, setting up a pull request validation process. Assuming we have just created a brand new app using ng-new, what we need to do first is to enable the Kubernetes reporter. Next up, we need to add a missing package, which is the Karma JUnit reporter, and we need to configure it to spit out the test results into a predefined location, preferably with attaching the information on which browser was just tested. Next up, we need to create an additional test task, which I like to call test CI. And the reason for it is that if you launch the default task, Karma will keep running, and it will prevent you from killing the browser window, making the build agent halt. So for that purpose, you need to attach a flag that --watch false, and also --code coverage to spit out code coverage from the Istanbul reporter. Next up, who is using containers? Yeah. All right, so as everybody knows, this is probably the de facto standard method of delivering apps nowadays. So we will add the Docker file, and as you can probably tell, this is a multi-stage build Docker file. So lines from 1 to 9 are the first stage where your actual app is being built inside a Node.js Alpine image, which is the lightweight version of the image. And once that's done, the products of that build are copied over to the next stage, which is actually an Nginx container. In order to get this running, we need two additional things. So first off, a Docker ignore. And the reason for Docker ignore is whenever you type in Docker build, you create a so-called Docker build context. And that means that everything in that context will be copied over HTTP or gRPC into the Docker engine. And as everybody knows, Node modules is probably one of the heaviest objects in the universe, so copying it like this is not a very good idea. The other file is the Nginx configuration, which makes the web server listen on port 80. Having had that, your container is ready to go. So we have just figured out what we need to do application side to get this ready for CI/CD. So now let's set up the build tasks for the pull request build definition. The difference between the pull request build definition and the target build definition is the fact that the pull request is not allowed to emit any artifacts. It's just here to check whether or not your job is any good. So this particular definition consists, oh, hang on, where are we? Over here. Okay, so this consists of 4 npm tasks, which is your classic build pipeline. So install packages, run the linter, run the tests, and finally build, followed by 2 tasks which harvest test results and code coverage results, followed by a final task, which is called build quality checks. And the role of this task is to validate the code coverage results, and if you fail to exceed a certain threshold, it will fail the build, which means that you need to keep writing unit tests. How awesome is that? All right. So it's also a very good practice to maximize task reuse by introducing task groups. So in order to do that, you can select all those tasks, right-click them, and create the task groups. So next time you want to use this, you can do it like this. So now that we have our npm pull request validation build, keep in mind that we've added the Docker file, so we have an additional build path for this application. So we also need to create a Docker pull request validation build. And all this thing does is just validates if your container is building properly. So once you have that, you're free to set the branch policy. So you go to repos, branches, select the branch, typically the master branch, and introduce the branch policy like this. So you introduce the number of reviewers that you like to have, and also additional rules such as check for attached work items, and also very important, check for attached comment resolution, because you want to make sure that everything is okay. Next up, you set the build policies with this button, which is not very well visible, but once you have it, you can select the build policies that you'd like to apply from the definitions that you've created, and also some very important stuff like invalidate that pull request build as soon as the target branch has been updated, forcing you to rebuild, which is actually important. All right, and like I said, multiple build policies. So that means that in a scenario that, for instance, Manfred has described, it is possible to have a separate build for each application in the repo, and you can even apply path filters. So that way, you only fire builds for the applications that have actually changed that single pull request. Yep, it's over here. So what we want to have is no dirty code in the master branch. So what I've just described looks like this. So we have Azure DevOps that's launching 2 concurrent pipelines. The first concurrent pipeline is the npm pipeline, which produces the test and code coverage result in JUnit and Cobertura formats. And in parallel, it launches the Docker build. And you can have as many of it as you want. Right, so at the end of the day, your build should look like this. And here's the summary. As you can probably tell, you have the code coverage here and all the tests here. So all is good. So we have validated the pull request, but now it's actually time to build this thing. So how do we set up the build process? In a pretty similar fashion. So we already have our task group, so we just reuse it and added one additional task. So that task is publish and copy build artifacts. It is important because it takes whatever's ended up in the dist folder, uploads it to Azure DevOps, and also acts as a trigger for a release process. This is the classic way to do it. However, since we're talking containers, let's put a little twist on it. So assuming we have removed that last task, what we can have is an additional build definition that builds and pushes the container image. Tagging is being done under the hood to a target Docker registry. So that can be Docker Hub, or that can be ACR, or Azure Container Registry. And finally, it has the publish build artifact in here. So in here, you just needed to trigger the release. So you can publish a git keep file, or if you're targeting stuff like Kubernetes, those can be Kubernetes manifests or Helm charts. All right, so how does the build pipeline look like? So we have Azure DevOps that runs the build, and when that build finishes on the master branch, it produces the test and code coverage results as usual. Then it fires up the Docker container build. It versions the image, emits the container image to a target container repository, and image the artifacts. Okay, so we're ready. So let's release this thing. So in order to release stuff in Azure DevOps, it is recommended to go into this area where you can find the release pipelines. So when you create a new release pipeline, you associate the artifacts that trigger that pipeline. And in here, you have the release pipeline editor. So the easiest way to get this up and running is to use one of the template releases. So there's a lot of scenarios covered already for you. But if you're feeling adventurous, you can model something yourselves. And let me tell you, pretty complex stuff is available. So this particular release pipeline, as you can probably tell, releases an application in test environment. Next up, in parallel, it runs multiple test suites. When those have passed, it promotes that artifact to the QA environment. It launches another set of tests for that particular environment. And last but not least, this application ends up in production. So in reality, what you should be thinking about when you want to release stuff. So I have Azure DevOps and I have a deployment target, so I can either deploy stuff directly, or alternatively, I can build a container image, push it to a Docker registry, and then have my deployment target consume that container somehow. All right, so next up, let's talk about Azure. So what you see in this picture is a picture taken a long time ago in one of Microsoft's data centers. And the smallest unit of isolation in those is a freight container, which has all the electrical appliances and actual hardware running inside. And the philosophy is that if a certain percentage of it breaks, then they replace the entire container. So what is Azure? So Azure is essentially a cloud platform to run cloud services at hyperscale. And let me tell you, that thing is actually more massive than you have anticipated. This is the current schema of all the locations of Azure regions worldwide, and that is 54 regions worldwide. And by worldwide, I mean worldwide. So what you see here is a product of a Microsoft research project called Project Natick, where Microsoft wanted to test if it's feasible to actually sync a data center for cooling purposes, which makes a ton of sense. So this is being sunk outside of Scotland. And you might be wondering, okay, so we have a cloud services, but what cloud services are dedicated to hosting web applications, such as Angular apps? So Azure Web Apps, also known as Azure Websites, which are running as a part of app services. So how does this work? So when we create a web app, we create an instance of it. So it comes with DNS, SSL, implicit load balancing if we're using multiple instances. So this is running in something that's called an app service plan, which is capable of running additional web apps as well as web jobs. And the app service plan is an abstraction that abstracts away a pool of underlying virtual machines which are running the Microsoft IIS server, if you're running on Windows, or Kudu. So Kudu is an engine used to run the web jobs. So it supports multiple deployment types like FTP, web deploy. It can deploy directly from GitHub or from Docker. And also Kudu is a deployment method. And creation is pretty simple because if you have the portal, you can use the top left corner to create a resource, and next up you create the web app. So what you get is this configuration blade where you select what's the target operating system that you like and what's the publish method. So you can either deploy files directly or you can use a container image. And currently, if you select the container image, your OS choice is constrained to Linux, but they're working on it. All right, so like I said, the app service plan is something on top of which the actual web app runs. So this is where you control your scalability settings, amongst other things. So as you can see, we have the option to either scale up or scale out. Scaling up means that if I have a VM with 2 cores and 4 gigs of RAM, I'd like to inflate it. I have 4 cores now and 8 gigs of RAM. That's vertical scaling. And scaling out, that's horizontal scaling. I have 1 instance of a web server running. I'd like to have 10. So that's essentially it. So if we enter the scale out menu, we can either control this manually, and we basically tell it, I'd like you to keep the number of instances constant, so let's have 4 web servers up and running. Or we can have some rules based on metrics, which will kick in on their own. So those can be CPU metrics, traffic metrics, memory consumption metrics. Using this, it is actually possible to deploy your application worldwide, for instance, Asia, Europe, and the Americas, and have something like a follow the sun pattern. So if Asia is awake, so we scale up Asia and scale down the other ones to control the costs. And if Asia goes to sleep, we scale up Europe. And when Europe goes to sleep, we scale up America. So it works like this. All right, so as you can probably tell, other deployment targets are definitely possible. However, I had to keep it short. And what you have seen is just the tip of the iceberg. I'd like this presentation to be a gateway for you into a larger and more interesting world. I'm hoping that it was informative, and I'd like to encourage everyone not to be afraid to try it out for yourselves. And in case you have any questions, I'll be available outside for a while. Thank you.